Hello, it's part 6 of Mini Robot Dog, and last time I had this walking almost dynamically using the inertial measurement unit to vary the rate of interpolation between positions of its feet, and that's driving a kinematic model that I did in the previous video, and that means we can move those legs back in perfectly straight lines or anywhere in straight lines in X, Y and Z coordinates. So we're using that inertial measurement unit data to try and make it balance on diagonal legs, as well as translating in the x-axis, which is backwards and forwards as it goes, to try and keep its centre of gravity on, and that almost worked and it looked pretty good. You can check back on the previous videos to see how I put this together and how I did all the maths in the kinematic model and everything else. We've come to a point now where I think I've got it to walk the best I can for this mechanical construction, and you can see the front legs are getting kind of folded underneath it in that bit of footage, and also basically there's quite a lot of slop and twist in it due to the mechanical assembly. So today we're going to look at that, and we're going to do a little bit of a redesign. Every joint of this robot was intended to have springs in so that it can be compliant, and that means that the legs can basically move separately from where the gears are, and we can measure that amount with a Hall effect sensor and 2 magnets which exist in every joint, and then we can actively drive that joint to catch up or do whatever in response. I've had to zip tie the springs out though, because basically the robot's a bit heavy and those springs stretch too much, and with the front legs like this, when it moves that front leg backwards, it actually folds under even more, and the compliance makes that worse. So I haven't been able to use that so far. So we're going to change the structure of how these legs look. At the moment it's quite well balanced because it's symmetrical, but I think probably we need to do something else with that. The other issue is we've got the leg pivot points are here, but the leg is right out here, and there's also backlash in every joint, as well as the natural flex due to the compliance and generally just the flex in the mechanism. So we do get this rather wobbly kind of leg that makes it twist when it stands on diagonal legs, just due to this offset. So we're going to try and get rid of that as well. There's also about 1.1 kilograms of steel in this robot, which is mostly all the M8 studding, nuts and washers, and also 48 bearings, which are 8mm internal diameter, so the same size as skateboard wheel bearings. There's 4 in each joint and 12 joints, and all of that steel adds up. So the new design is going to take some of that out as well. But before we look at the new design, this is just a quick ad for ways you can support the channel, and that really makes all the difference to the projects. So I'm publishing all of this as open source as I go, or at least as I'm confident enough it works to some extent, and I'll be doing that with the new design as well once I've put the electronics in and it works. So if you want to support me on Patreon or for a YouTube channel membership, then those links are in the description to this video, and that means you can get all the videos up to a week early and sneak peeks and pictures of what's coming up and be involved in that discussion. I have some affiliate links in the description below, and some of those are free trials you can sign up for, and if you do sign up for them it won't cost you any more and I'll get some money. I also have a merchandise store where I sell t-shirts with pictures of openDog and various other robots and things that I've built over the years. Right, let's have a look at the new design. And that looks like this. So now we have the legs all facing forward, which means that it's not symmetrical anymore, but hopefully those front legs don't get folded under each other as they were before, and we can convey force with the ground much better. And you'll notice this is really similar to the MIT Cheetah and Boston Dynamics dogs. Of course, we've lost that offset now on the front, so it looks a lot wider, but that's just because the hip pivot is directly above the foot, so we should lose that twist when we stand on diagonal legs. And the hip servo is on the outside here because that's the only place there's now clearance, because on the inside we've got the shoulder gears. Now all of the construction now is based on aluminium tube, and it's going to be aluminium tubes running through all of the axes there, and we're just going to put plastic clamps on the outside to stop the legs falling off, and there's clamps built into the pieces essentially that actually clamp those. You can either put a nut and a bolt or a zip tie through, but I think they're going to be pretty tight anyway, so we should be able to lose all of that steel and all of the bearings, and I'm just going to run the plastic straight on aluminium with grease. So comparing the two side by side, you can see that the feet are spaced to approximately the same dimensions there, so it's pretty much the same footprint, just this one looks a lot wider, which means there's probably more space for electronics and batteries and things in the middle as well, but also it should be a lot more stocky and a lot more substantial, and hopefully we can get rid of some of those mechanical issues that we've had with the first version there. So here's some of the leg parts. We've still got some more parts printing, but we can get on with the leg assembly. So as with the previous design, lots of the parts are very similar. We've got these leg sections for the upper leg, which are two parts that screw together. So there's screw holes in the bottom, and then there's a plate that screws on the top to brace it. The upper leg parts as well are a very similar thing. So we've got that mechanism for the compliance, which is just plugged into a recess, so that will get glued in. And then we have a free rotating axis through there, which will be on the 10mm aluminium tube. And we've got that clamp there to hold the other axis where the hip fits. But we do have to take some parts off the old one, including the 12 servos mainly, because I'm not just going to buy another 12, and various other bits that are the same, the electronics and everything like that as well. So this is the middle of the leg, and we've got that aluminium tube in the clamp there and the servo fitted with the gear. So we put a nylon washer on, followed by the intermediate gear that's driven and has the compliance mechanism on. And I've just bored these out with the drill bit, so they're quite free moving, but I'm also putting silicone grease on the tube there. So after that one, it's then followed by the rest of the leg. So that's all been assembled. I've got my stopper on the outside, which is also zip tied up, and that seems to be pretty tight. And of course, each stage has those nylon washers in between it to give them spacing. So that seems to run pretty well. So those are my 4 legs, 2 lefts and 2 rights. I've stolen the servos, the plastic fingers and the Ninja Flex rubber feet off the old robot, which is just out of shot here on its back at the moment, having all the parts taken out of it. So the next stage is the hip to shoulder mechanism. So the shoulder attaches onto here, and again we've got that aluminium in a clamp, and then this is free to rotate this way, which makes that hip mechanism. So we need to put the intermediate gear on again, and then the leg will attach on there, again with a pair of those fingers and the spring. Right, that's all 4 legs built, with the mechanism of course on the top of everyone and the stopper, and everything seems to work pretty well there. So those gears feel pretty tight, and that feels pretty substantial altogether, so I think that's going to be a much better design. And now of course that fits onto the mechanism that allows the leg to turn sideways, so we need to build the body frame. And that is made of those frame parts I showed at the beginning, and these are clamped up with zip ties to actually squeeze onto this aluminium box section and the aluminium tube. So that's actually made a really rigid construction, and of course it's really light because there's no extrusion in it, which is more solid than the aluminium tube, and we just got the 3D prints, no nuts and bolts, so that seems to be pretty good. So we need to put the ends on, and of course those hip axes exist in each side. So those are my pairs of legs which move that way. So now all we need to do is put the end on that frame and put the servos on that activate the hips. Right, here it is. There's a pretty good size, I think, compared to the other one. Obviously it's much wider, so we've got lots of space for electronics, and it feels really substantial. So all that's left for the mechanics is to drive these gears so that we can move the legs sideways. So that servo fits on the outside here for really long gear, and that's so I can fit the servo onto one piece of the frame and the other end of the gear onto the other piece of the frame. And I've got a piece of 10mm aluminium tubing shoved in the length of this gear, and that just goes into a bushing at this end, again with some silicone grease. So now of course this servo turns that axis exactly the same as it did in the last version. And I've just made a stand to put it on here, which is made of extrusion and a couple of 3D prints that lock into the frame so it's nice and stable for testing. So we've taken all the motors out of this one, of course, so it's all floppy now, but comparing the design at the front as I did at the beginning, of course we've got the shoulder pivot is now around this point, and that's directly above the foot, so any force from the ground gets applied directly into the joint, rather than it being off centre as it was in this one, which causes that twist on diagonal legs and basically tries to push the leg up that way because the pivot's here but the foot's out here. Otherwise they are pretty similarly sized in terms of the footprint and the leg spacing, so we just get much more value with this one in terms of its space inside, because all that space for electronics is much wider and much stockier, so hopefully it'll be more mechanically reliable. I've started to construct a shelf in the middle here, which is part of the robot, and that's for the electronics to sit on, which we made last time. Obviously that's in a yellow box at the moment, but we'll reprint that in a nice orange colour to match the colour scheme. So there's absolutely no problem fitting that in there, and we'll probably put the batteries in either side. I've started to strip this one down. Obviously we've got the servo distribution boards, we've got the little LCD that tells us the voltage on the battery, we've got all the Hall effect sensors and those connectors and all this wiring to strip out, as well as battery mounts and a power switch to go into the new one. There's quite a bit more work to do before we can get this up and running, and that's going to happen in the next video where I do put the electronics in, and probably all the Hall effect sensors, although I may try and make it work without them. We'll try and get it up and running at least as well as the last one. It'll be very interesting to see how much more rigid this is with those new leg pivots. Of course there is a limit to what we can do with radio control servos. We could put more expensive servos in, perhaps brushless or coreless servos, or we could move right up to proper robotics servos like the Dynamixels. But at the moment I'm sticking with the really cheap servos so that the design is accessible, and I'll be publishing all the CAD and code probably next time when it works, or at least I'm confident it's going to work well. Of course, it will be available to YouTube channel members and patrons for anyone who wants it, who supports me on those platforms. So if we look at the MIT Cheetah, or one of those dogs, you can see that the legs do move a lot faster than they do in this, and really we've got this limitation of the servos with the gearing on to try and make it this size with enough power, but obviously we do lose some of that agility. So I think if this works well, then after this dog I'm going to move back onto brushless motors, and there'll be another designer, and essentially we're working our way back up to make something the size of openDog, but perhaps something not as heavy. So some of these design techniques with the aluminium tube and the 3D print and the zip ties have been really good lessons in learning basically how to make something light and hopefully how to make something agile in the future. So don't forget to subscribe for more updates on this project and some of the other projects. At the moment we're pretty much doing robot dogs every week, and if you'd like to support me on Patreon or for a YouTube channel membership, then those links are in the description below. Alright, that's all for now.